Hello everyone, my name is Jonathan and welcome to my video discussion about IT Essentials version 7. In this video, I will be discussing the first two sections of Chapter 5 Networking Concepts. In Section 5.1, we will talk about the different components and types of computer networks. We will also be discussing several internet connection types. In Section 5.2, we will discuss the different networking protocols and its services. We will also talk about the transport layer protocols and importance of the port numbers. So let's get started. In a network environment, there are three important things or devices that must be present in order for our data or information and resources to be shared to others. The first one are the end or host devices. These are computers, servers, printers, and other devices that the users are using within a network environment. They are called end devices because they are at the end or edge of a network. They are also considered host devices because they host network applications such as web browsers and email clients for the clients to use. Another important device present in our network are the intermediary devices. They are responsible for ensuring the successful data transfer from a source, which is a host device, to the destination, which is a host device as well. Example of these devices are routers, switches, access points, and modems, which we will be discussing in a while. Lastly, we have the different networking media. This is considered as the road or pathway for our data to use to travel from source to destination. We should always keep in mind that the main reason why we have networking is to share our information and resources to other users. While we are doing this, we need to make sure that no data will be lost as it travels through the network. With this, we need to understand how networks are being designed and implemented through different networking topologies. The simplest topology is a personal area network or PAN, which covers a limited range of up to 10 meters only. It uses the Bluetooth technology to connect devices. Next is the local area network or LAN. Typically, it's a wired network, meaning we use cables which connects devices in a small geographic area or location. This network is managed by a local administrator. The Virtual Local Area Network or VLAN is implemented to segment large network into several subnetworks or groups to isolate data traffic to specific network segments. This means that you can share information or resources whether you are in different locations as long as you belong to the same VLAN group. A wireless LAN or WLAN is just the same as LAN, but without the physical cable connection. It is actually a way of extending our LAN through wireless connectivity. A wireless mesh network or WMN uses multiple access points to extend the WLAN. The typical range of WLAN is 150 feet or 46 meters indoors and 300 feet or 92 meters outdoors. So if you want to extend your Wi-Fi connectivity, WMN is of great help. A metropolitan area network or MAN is a network that spans across a large campus or a city. The network consists of several buildings connected through wireless or fiber optic media. As we all know, Wide Area Network or WAN connects multiple networks that are in geographically separated locations. In order for these networks to communicate, they need a service provider to grant them access and connectivity. Lastly, a virtual private network or VPN is used to securely connect to another network over an unsecure network, such as the internet. There are two types of VPN connectivity. These are site-to-site VPN and remote access VPN. Teleworkers or mobile workers are the one who mostly use this kind of network. Moving on, We all know that the first internet connection available in the market is the dial-up connection. This connection uses PSTN or public switch telephone network, which may be of the telephone line as you see in the image. It could also be a fiber optic, microwave transmission, or communications satellite. In order to access the internet, you need to dial a specific number to connect to your ISP. Then, your ISP will open the internet line for you. With this connection, only one task can take place. Either you can run internet or talk on the telephone. And that is the main disadvantage of a dial-up connection. Its speed is also very slow, from 28 kilobit per second to 56 kilobit per second. With that speed, we cannot neither watch online movies nor play online games. Next, we have the ISDN, which stands for Integrated Service Digital Network. This connection is almost the same as the DSL. It is a set of international communication standards designed in 1980 and was improved during the 1990s. It is a digital network to transmit voice, image, video, and text over the existing circuit switch PSTN telephone network. Devices such as analog phone, a fax machine, or a computer are connected to an ISDN terminal adapter, which converts different types of data into an ISDN format in order to share the same digital PSTN network. There are two known types of ISDN, the basic rate interface and the primary rate interface. In broadband connections, equipment that are seen here are used to connect to or transmit broadband signals. It is called broadband because it uses and provides a wide band of frequencies. The wider the bandwidth of a channel, the greater will be the information carrying capacity. You can achieve speed up to 100 Mbps. But of course, it depends upon the cables we use. Like in the case of a coaxial cable, data transfer speed may vary, but in optical fiber cable speed will be higher. Generally, its speed is in megabit per second, but it can be gigabit per second also. A good example of this is an ADSL broadband, which we use in our homes and offices. Let us now describe the characteristics of DSL, cable, and fiber. Basically, both the DSL and cable use modem to connect to the internet through an internet service provider or an ISP. In a DSL internet connection, both voice and internet data can flow over the same telephone line at the same time because of the DSL filter. This component filters the voice and data. The speed of DSL varies between 5 Mbps to 100 Mbps. There are different types of DSL. We do have an ADSL, or the asymmetric digital subscriber line, which is what we usually have at home. With ADSL, the downloading speed is higher than the uploading speed. Next, we have the SDSL, or the symmetric digital subscriber line. Here, both the upload and download speed are the same. This is typically used in businesses. Lastly is the VDSL, or the very high bitrate DSL. This is the fastest form of the DSL because it uses copper wire, but it is for a limited distance only. On the average, VDSL is 3 times faster than the ADSL. Cable internet connection is using coaxial cable instead of telephone lines. Typically, cable television companies are the one that provides this internet service to the customers. During peak hours, there is a slowdown with the speed because all customers are using at the same time and they are on the same cable line. A fiber internet connection provides the fastest internet speed today. It can provide download and upload speed of up to 1000 Mbps. It is made of glass or plastic and uses light to transfer the data. Data can travel to long distances without any losses. That is why this is usually used in backbone networks, large enterprise environments, and large data centers. Of course, this is more expensive than the DSL and cable. Satellite internet uses the path of the outer space. In rural area where there is no cable or DSL connections, this could be their best option for connectivity. This does not require a phone line or cable. Instead, it uses satellite dish for two-way communication. The dish transmits and receives signals to and from a satellite that relays the signals back to the service provider. Download speed could reach up to 10 Mbps or more, while upload speed could be about 1/10 of the download speed. Since satellite orbits the Earth there could be some sort of a delay as data travels. That is why this is not the best option for time-sensitive applications such as video gaming, voice over internet protocol, and video conferencing. Next, we have the cellular internet connection. In this network, radio waves are used for the transfer of signal to and from the mobile phone. This technology relies on cell towers that are distributed throughout the user's coverage area to provide seamless access to cell phone services and the internet. Generally, these cellular towers are connected through a wire or more specifically optical fiber cable. These optical fiber cables are laid under the ground or ocean for providing national or international connectivity. During the use of the internet, smartphone transmits a signal in the form of electromagnetic waves. These signals will be picked up by the tower and then convert them into a high-frequency light pulses. Continuous development are on the way to improve the speed rate of the data transfer. Another type of internet connection is the mobile hotspot and tethering, wherein we link our device through Wi-Fi, Bluetooth, or USB cable to another device to provide internet connection. I hope you understand what we have discussed so far. If you have any questions, you may use our discussion board and post your inquiries there, and let's discuss together with all of the participants. We will now move to 5.2, Network Protocols, Standards, and Services. TCP/IP model is a standard protocol used for data transmission over a network. TCP, which is the transmission control protocol, is under the transport layer of the model and is responsible for ensuring that the data could reach the destination reliably and in order. IP is the Internet Protocol, which is responsible to the addressing in order that the data could be routed to the intended destination. If we try to look intently on the transport layer, you will see two types of protocols, the TCP and UDP. Let's discuss them one by one. As I mentioned earlier, TCP is responsible for ensuring the reliability of data transfer from source to destination. It means that it makes sure that all of the data arrives at the destination. There are three operations that are happening in this protocol. Number one is the numbering and tracking of data segments to a specific device from a specific application. Let's observe what is going on in the given network. As the file is about to be sent using the FTP, the TCP records that communication and then segments the data into 6 parts. The information about the number of segments will be the basis for a successful receipt of the entire data. By the way, we segment the data so that it will be easier and faster to move them from source to destination. When the data is received by the destination, it will send an acknowledgement that data has been received, and that is our number 2, acknowledging the received data. This validates that the data has reached its target destination. Suppose the remaining 3 segments did not reach the destination. Definitely, the destination will not acknowledge anything. This will prompt the sender to resend the remaining segment, and that is our number 3 operation, which is retransmitting any acknowledged data after a certain period of time. Since TCP keeps tracks of the data segment, it could identify for any unsuccessful data transfer. With that, the remaining data segment will be resent to the destination, and the destination will again acknowledge the received data and forward that packet to the source, alerting the source for a successful receipt of the data. On the other hand, UDP or User Datagram Protocol works differently. It does not provide any form of reliability, meaning to say, it does not care whether the data has successfully reached the destination or not. Let us observe what happens in the given network. When a file is about to be sent over the network, UDP segments the data and then sends all of it to the destination. UDP uses the best effort delivery protocol. This is considered unreliable because there is no acknowledgement that the data is received at the destination, as you see in the animation. Moving on, what are port numbers? According to one definition, port numbers is a protocol used to uniquely identify a specific process to which an internet or other network message is to be forwarded when it arrives at a server or destination. It gives a unique identity that separates it from the other process or protocol. There are 3 types of port numbers. These are well-known ports, registered ports, and the dynamic or private ports. The range of well-known ports is from 0 to 1023. Registered ports are ports that are assigned by the Internet Assigned Numbers Authority or IANA or by Internet Corporation for Assigned Names and Numbers or ICANN. Meaning to say, it is for use with a certain protocol or application and it must be applied and registered. The range for registered ports is from 1024 to 49151. Dynamic or private ports are not assigned, controlled, or registered, meaning anyone can use these ports that ranges from 49152 to 65535. To have more details about port numbers, I encourage you to take the CCNA Introduction to Networking version 7 training. There are a number of different types of application layer protocols that are identified by TCP or UDP port numbers at the transport layer. We do have the World Wide Web related protocols, email and identity management protocols, and the file transport and management protocols. We also have the remote access protocols and the network operations protocols. The next slide shows summary table of all of these application protocols listed in port number order. Okay, so let's talk about now some close proximity connections that uses wireless protocols as well. The first is the Bluetooth. Bluetooth is a radio wave technology that is mainly designed to enable wireless communications over short distances. It could connect up to 7 other Bluetooth devices. Under the IEEE 802.15.1, these devices operate in the 2.4 to 2.485 GHz radio frequency range. On the other hand, the RFID, or the radio frequency identification, is a wireless non-contact use of radio frequency waves from 125 MHz to 960 MHz to transfer data. It can read and capture information stored on a tag, which is called an RFID tag attached to an object. There are two types of RFID tags. The first is the active RFID tags, which has a battery and can broadcast their ID up to 100 meters. The second is the passive RFID tags that rely on the reader that uses radio waves to read its tag. Passive RFID has a range of 25 meters only. Typical application for this is for inventory and sales. Next, we have the Near Field Communication, or the NFC. It is a short-range wireless technology that makes our smartphones, tablets, wearables, payment cards, and other devices even smarter. It is actually a subset of the RFID standards, and it uses a frequency of 13.56 MHz. With NFC, you can transfer information between devices quickly and easily with a single touch, whether paying bills, exchanging business cards, downloading coupons, or sharing a research paper. It is designed to have a more secure method of completing transactions. Another wireless protocols that are becoming more popular are the Zigbee and the Z-Wave. These protocols are typically used for smart IoT home solutions. If you want to know more about this, I encourage you to take also the IoT training that we have. Moving on, Zigbee is a wireless technology standard that defines a set of communication protocols for short-range communications. You might wonder, we already have Wi-Fi or Bluetooth for a short-range communication. Why is it that there is this Zigbee? Well, Zigbee standard is specially created for control and sensor networks. It is a standard that addresses the need of very low-cost implementation of low-power devices with low data rate for short-range wireless communication. It is one of the most commonly used standards for the Internet of Things. With the Internet of Things, we try to interconnect devices such as lights, door locks, switches, smoke detectors, fans, and other appliances to improve a certain process or make these devices smart. In addition, we can manage and control these devices remotely. These devices, which we call Zigbee clients, require low power only because these devices use only battery to power up. In addition, they only require low data rate because they are just sending a signal to another device. This gives Zigbee an advantage over the Wi-Fi and Bluetooth. In Wi-Fi, it uses a lot of power which is not needed in an IoT environment. And Wi-Fi uses high data rate which could somehow overwhelm the IoT network. As for Bluetooth, we cannot use this because it has a limitation of 7 connections only. For Zigbee, it can support up to 65,000 devices. On the other hand, Z-Wave technology is a proprietary standard that is now owned by Silicon Labs. However, a public version of the interoperability layer of Z-Wave was open source in 2016. Z-Wave can transmit data up to 100 meters but has a slower data rate than Zigbee at 9.6 to 100 kilobit per second. Another important wireless protocols are the cellular generations. Over time, we have seen the progress and development of these generations, from less than 9.6 kilobit per second for the first and second generation, up to a maximum of 3 gigabit per second for the fifth generation. This 5G supports a wide variety of applications including augmented reality or AR, virtual reality or VR, smart homes, smart cars, and other smart solutions. Moving on, we all understand that any end or host device that are connected in a network performs a certain role, and most likely, they are connected to a certain server that provides services to one or more clients. Some of the examples of the client-server roles are as follows. In file client and server, the file server stores corporate and user files in a central location. The client devices access these files with client software such as Windows Explorer. In web client and server, the web server runs web server software and clients use their browser software such as Windows Internet Explorer to access web pages on the server. In email client and server, the email server runs email server software and clients use their mail client software such as Microsoft Outlook to access email on the server. Other servers that are common in a company or organizations are as follows. First is the DHCP, or the Dynamic Host Configuration Protocol Server. The function of this server is to provide IP addresses for all the clients. Second is the DNS, or Domain Name Service Server. This is used so that IP addresses can be translated into a name that is readable and understandable by anyone or vice versa. This will allow us to, instead of memorizing and writing IP addresses of the sites we visit, we will just simply write the corresponding names given. In this example, you will see that a client types in www.cisco.com. This means that the user would like to access the website. In step 2, the DNS will try to match the domain name requested by the user with the corresponding IP address of the domain. In step 3, a DNS query is sent to the server to request for the IP address. In step 4, DNS server will give the DNS query response which contains the IP address of the website. Finally, the domain name is resolved, meaning to say it is being verified that the address being typed by the user is correct. Print server is very common in any workplace, even at home. We use this so that we can share our printer to others. It allows us to maximize the use of our resources. Next, we have the file server. With this server, it provides facility to transfer files between a client and a server through the File Transfer Protocol, or FTP. Since FTP has security flaws, FTPS, SFTP, and SCP has been introduced to improve secure file transfer. A web server allows the clients to access different web resources using the Hypertext Transfer Protocol, or HTTP, or the Secure HTTP, or HTTPS. HTTP is a set of rules for exchanging text, graphic images, sound, and video on the World Wide Web. HTTPS adds encryption and authentication services. using secure layer or secure sockets layer protocol or the newer transport layer security protocol. HTTP operates on port 80. HTTPS operates on port 443. To better understand how the web browser and web server interact, let us look at the given example. In step 1, the browser interprets the parts of the URL. The HTTP, which is the protocol or scheme, and www.cisco.com, which is the server name. In step 2, the browser then checks with the DNS to convert the name into a numeric address, which we discussed earlier. With HTTP requirements, the browser sends a GET request to the server to ask for the index.html file. In step 3, the server sends the HTML code for this web page back to the client's browser. Finally, the browser interprets the HTML code and formats the page for the browser window. Email server is a server that sends, stores, and manages email across a network. It uses several protocols such as Simple Mail Transfer Protocol or SMTP, Post Office Protocol or POP, and Internet Message Access Protocol or IMAP. Next is the proxy server. It acts as a storage or cache for web pages that are frequently accessed by devices on the internal network. It is useful because since it stores information about web pages, it minimizes the use of its resources. Another advantage of this is that proxy server can effectively hide the IP addresses of internal hosts because all requests going out to the internet are sourced from the proxy server's IP address. Another server is the Authentication Server. The purpose of this server is to control and manage network access using the AAA standard, which is authentication, authorization, and accounting. Lastly is the Syslog Server. This server is used to store information about the activity inside your network. It will help you analyze network performance and troubleshoot network issues. That's the end of our discussion for now. Please do not forget to do all activities in our module to check your understanding about the topics being discussed. If you have any questions, you may post a comment in our discussion board or you may ask me during our live session. Thank you very much and hope to see you in our Part 2 discussion.